Have you ever wondered about that little object holding your grocery list to the refrigerator door? It seems so simple, just sitting there. But what if I told you it is performing an incredible, invisible dance? What if that small, unassuming magnet is locked in a constant push or pull with the very planet we live on? It is true. Magnets are all around us, working silently, performing feats of strength and defying gravity. They possess a mysterious power, a secret force that can reach out through the air without touching anything. It is a force that can either say, "Come here," "Go away," and it does it all without making a sound. Let us pull back the curtain on this amazing phenomenon and explore the secret behind this captivating push and pull. This force is not magic. It is a fundamental property of our universe, a force called magnetism. Hold two magnets in your hands and, as you bring them closer, you can feel them start to interact. A gentle tug or a stubborn push, even though your hands are still inches apart. It is like having invisible springs between them. This unseen energy is what makes compasses point north, what helps electric motors spin, and what allows a maglev train to float above its tracks. It is a powerful, hidden world just waiting to be explored. So, what is a magnet really? Let us break it down. A magnet is a special object that creates an invisible area of force around itself. We call this area a magnetic field. You cannot see it, you cannot smell it, you cannot hear it, but you can definitely see and feel what it does. This field gives a magnet its power to pull on certain metals: iron, nickel, cobalt. Think of it like the magnet's personal bubble of influence. Anything inside this bubble can be affected. It is the field that is the real star. Every magnet, no matter the size, has two special spots. We call them the poles, a north pole and a south pole. Sprinkle iron filings around a bar magnet and they bunch up at the ends, showing the poles where the force is strongest. You cannot have a magnet with just one pole. Break a magnet in half and you get two smaller magnets, each with north and south. Why does this happen? The secret is hidden deep within the atoms. Inside the material are microscopic magnetic domains, each a miniature magnet. In a non-magnetic piece of iron, domains point every which way so their forces cancel out. No overall magnetic field. Expose iron to a strong field and it is like a drill sergeant shouting, "Attention!" Domains snap into formation. Pointing their north poles one way and south poles the other, they stop canceling and combine into one big field. Teamwork at the atomic level. That is how a magnet is born. Now the really fun part, the push and the pull. Magnetism follows simple, predictable rules. Opposites attract. Bring the north pole of one close to the south of another, and you feel a pull. They want to snap together, like perfect puzzle pieces. Like poles repel. Two north poles push away with a springy resistance. Same with two south poles. Field lines flow out of north and into south. When N meets S, their lines link, forming a strong, unified field. It is like two rivers merging into one more powerful river, working in harmony. Force like poles together, and the field lines clash and bend, creating high pressure between them. That is the repulsion you feel. Like trying to merge two water jets head-on, they just splash away. The fields are not cooperating, they fight, and the magnets are forced apart. You do not need a lab coat to be a scientist. Grab two fridge magnets, the stronger, the better, and bring them together. One way they snap, attraction. Flip one and feel the cushion, repulsion. Now touch a paper clip with a magnet, then pick up a second using the first. Add a third, maybe a fourth. The magnet temporarily turns each clip into a magnet, induced magnetism flowing down the chain. Slide a ring magnet onto a pencil. Flip a second, so like pole's face. The top ring hovers above the bottom. Repulsion beating gravity. Magnets make sound. A current in a coil meets a magnet. The cone vibrates, and you hear music. In your headphones, your car, your home. Magnets store data. Hard drives flip tiny magnetic regions for ones and zeros, and giant archives still trust magnetic tape. Small motors power vibrations and spin disks. In medicine, supercooled magnets in MRI machines align protons and let doctors see detailed images, non-invasive and life-saving. From maglev trains to fusion reactors and even toys, magnets scale from tiny to colossal to shape the future. We learned how aligned domains create a field, how every magnet has two poles, and how opposites attract while like poles repel, seen in our simple home demos. Handle magnets with respect. Strong ones can pinch, small ones are hazardous if swallowed, and keep them away from credit cards and old magnetic media. Magnets teach us about forces, fields, and matter, and how tiny atomic spins add up to forces strong enough to lift a train. So, next time you see a magnet, see the dance of the domains, feel the push and pull, and appreciate the silent power shaping our world. Now that is some attractive science.